the data is like appropriately nominal.
Yeah, excellent. So if the data are as they should be, that is, if we have if JMP has identified the data as character and numeric data, right? Character data we know has the red histogram and numeric data has the blue triangles, right? And all the columns except for the soil should be numeric, right? Is indicated by the blue columns. So what we want to do is visualize our data. And so we're going to use the graph and graph builder tool to do that. And we're just looking for a correlation between soil as our independent variable, and then we're going to look at any of these other soil health, soil quality variables to see if any of them are indicative of what the farmer is identifying as fertile, shaded, or sterile. Okay, so go to the graph builder, and then drag soil to the x-axis. And then all we're going to do is just go down the list of variables and try them out and see if there's any relationships that we can notice between soil as the independent and total nitrogen, total carbon, pH, EC, etc. And I'm going to use the column graph, and I'm also going to put in some error bars. So your summary statistics should be mean. I'm using, yeah, like I said, the column graph, your error interval, instead of being auto, make it standard deviation. So that'll put in some error bars there. And so what we're looking for is some type of relationship where we might expect total nitrogen to be higher for fertile soil versus the shaded and the sterile soil, or at least higher for the fertile soil than the sterile soil. And shaded is kind of a hard thing to predict, right? Because shaded doesn't necessarily mean that there's a difference in soil quality or soil health, but what it does mean is that there's a difference in the site conditions relative to the other ones. And I don't know, because I didn't talk to the grower, if fertile and sterile is an indicator of yield, quality, or both. Okay, so I don't know. And those yield and quality are different oftentimes, right? A lot of times, like with wine grapes, for example, where you have high yield, it's not necessarily associated with high quality, right? High quality is oftentimes associated with like a lower yield and actually soils that are maybe more poor from a typical soil fertility perspective or a soil health perspective. So nitrogen doesn't really do much for us. So I'm going to pull in carbon. And to do that, I'm just going to put carbon on the top of nitrogen, and you'll see it turns into that kind of hexagon. And carbon doesn't change anything. So I'm going to pull in pH. pH is even less sensitive, right, to the differences that the farmer noticed. Let's try ECEC. And ECEC, there might be something there, right? So interestingly enough, where we see a low effective cation exchange capacity, we see what the farmer classified as more fertile soils, or more fertile growing conditions, which is kind of opposite of what we might expect. Although we also notice that the ECEC levels are pretty low in general, right? So they go from a little over 1 to around 4, right, which is low, but not unexpected for a highly weathered soil from Costa Rica. So let's see if UNFAO is sensitive to it. And it's not, right? UNFAO raises the pH, right, of all of the soils to 7 and then puts ammonium on cation exchange sites, right? And so here we see that really the soils have pretty similar UNFAO CECs. We'll see about USDA CEC. So same with USDA CEC. Oh, wait, is that, yes, USDA CEC. So let's see about calcium. So calcium does show some differences, right? We see a trend of our fertile areas having a lower quantity of exchangeable calcium than the areas that the grower called less fertile or poor growing conditions. Let's see if potassium is similar to that. And potassium is not quite as sensitive, right, as calcium was. And what about magnesium? So magnesium also, right, lower, but fertile 2 and shaded and fertile 2 and sterile are pretty similar. So far, like ECEC and the quantity of calcium are potential indicators, right, of differences in soil types as identified by the grower. What about exchangeable acidity? Not really. And if we do total acidity, so total acidity looks like an indicator, right? At least we have our fertile soils clustered on the lower end and our shaded and sterile soils clustered on the higher end of total acidity, which is what I would expect, right? I would expect total acidity because hydrogen and aluminum, right, which are incorporated in the measurement of total acidity, are not necessary for plant growth. And even aluminum is can be toxic, right, to plant roots. All right, so what about bioaccessible lead? I don't think so. Bioaccessible cadmium? No. Total lead? No. All right, so what we came up with is BCC, quantity of exchangeable calcium, and total acidity. Right, all the variables that we looked at and we determined during the quarter for our Costa Rica soil, those ones have some kind of relationship with the grower's classification of the soil's fertility status or the soil's health status. Oh yeah, magnesium. Let's look at that. Yeah, magnesium too. What did potassium look like? Not as sensitive. No. Okay. All right. So one thing that I wanted to show you in this discussion was how easy, right, it is to use a tool like this. There's other tools, certainly other statistical software tools that you can use to do it, but how easy it is, right, to just look at a bunch of different variables and visually make some inferences between what things could be correlated and what things might not be correlated. And so we did that. And what I'm going to ask you to do in a few moments is to pick one, any one, and make a figure of it and create a caption for it that is visually appealing like you've done before and has a caption that allows the figure to stand alone. But before we do that, let's take a look at one other thing, and that is to try and understand why. So what we see is where we have lower exchangeable calcium, lower exchangeable magnesium, and lower gesundheit, lower effective cation exchange capacity. That is what the grower identified as a more fertile area for growth, right? Which is kind of counterintuitive, right? So it's possible, right, that the grower is, I don't know, but it's possible that the grower is saying that all those are areas that produce higher quality coffee too. I don't know, but it's possible. So why is that? What like soil property? And I've looked at the data, so I have an idea. But if you go back to your spreadsheet in Excel, what, so we're looking at it here. What else could give us an indicator of what sterile soil and shaded soil have some similarities versus the two fertile soils? Yeah, Hugo.
Um,
Texture. Yeah. So what do you notice with texture? Yeah. So we don't know what the percent clay is, but these textures were determined in the field by some Cal Poly students who collected the soil samples this past summer. And in general, right, what Hugo's pointing out is that, and I'm sure others of you noticed this, is this where we have finer textured soils, those are areas that the grower classified and perhaps data has pointed out over time are either less productive or lower quality or both. And where we have sandier soils, our sandier soils, we got loamy sand, which is very sandy, and some loams and then sandy loam. Those are the areas where the soils produce either coffee of higher quality or more productive. And I'm thinking maybe it's quality, not positive, but maybe it's quality. Does anyone know about coffee, growing coffee? Maybe it needs good drainage, right? And especially since there's probably plenty of rain, right, in the area. So perhaps since rain is probably not a limiting factor like it would be for areas around here, it's possible that coffee needs good drainage. Probably is less energy for the roots to grow through the soil in a coarser textured soil and a finer textured soil. So that's might also be it, right? But it definitely like tells us that we're maybe scratching the surface of understanding why that is. Anna, did you have a question or a comment? Okay. So it's interesting, right? But some research begets more research, right? Trying to find the answer. So what I'd like you to do, for it's like 1:20 right now. So in the next like 10 or so minutes, pick one of these correlations between soil and exchangeable calcium or exchangeable magnesium or total acidity and create a figure that looks at that relationship and then has a caption and submit it. There's a assignment on Canvas that was says that was due yesterday because I had the lab that has lab or the activity group yesterday turn it in. And it's we'll make it due at 5. So if you don't have your laptop with you, that's fine, but you should have plenty of time to get it done right now. So everybody submit whatever one they want to do.